Hello Year 12 and welcome to your first lesson on AS Chemistry. Today we're going to be reaffirming some things about the atom to make sure we're on a really solid foundation before we start with the rest of the course. We're covering the first 4 spec points of the course today, talking mostly about how we define what protons and neutrons and electrons are, where they live, what their masses are and what their charges are. I thought we'd start with a brief history of the atom, and it was the Greeks that first came up with the idea of something that is so small it could not be cut in two. Atom actually comes from the Greek word atomos, meaning indivisible. Dalton was the next person to talk about atoms seriously, and that wasn't until the 1700s. He was a British scientist, and these 5 points that he said about atoms, if we ignore subatomic particles, are quite true. All matter is made of atoms. All atoms of a given mass are sometimes identical in mass and properties. We'll talk about why that's untrue later. But the stuff about compounds and chemical reactions are very true and a very important piece of chemistry. Thomson was the next person to take the idea further after the discovery of negatively charged particles called electrons. Thomson thought that atoms were still solid spheres, because that model works really well, that were positive, but the negative electrons were stuck inside the sphere like a plum pudding or a Christmas pudding. So if you imagine the cake of the Christmas pudding being the positively charged sphere and the raisins being the negatively charged electrons, that's about what he was thinking. But it was Rutherford who disproved this model. If you had a solid positive sphere and you fired a load of positive alpha particles at it, like he has done here, you would expect all the alpha particles to bounce backwards. However, most of the particles go straight through. And that's because most of the atom's empty space. A few of them go through, but are deflected. So that means they've not hit anything positive, but something negative has pulled them away. This is where the idea of orbiting electrons came from. So this is where we're at the moment. You'll notice the positive protons and the neutral neutrons are in the center, or the nucleus of the atom, and the electrons are orbiting around the outside in shells. Electrons are a lot smaller than the protons and neutrons. Their mass is 1/2000th of the mass of protons or neutrons. Notice that we now think of electrons as having mass, just a small mass. And the charges of electrons are negative. To work out the number of protons, we're just going to take the atomic number, which is the smallest and always an integer number on the element card. Sometimes it'll be at the top, sometimes it'll be at the bottom. Just make sure it's the smaller number. The electrons we work out by subtracting the charge from the number of protons. So for example, if we had carbon with a -1 charge, we would do 6 minus -1, which is 7. And the neutrons we work out from taking the atomic mass, which is the larger number, and subtracting the number of protons. But this atomic mass for carbon is 12.01. And that can't be true, because protons and neutrons both have integer numbers of mass, and electrons don't weigh enough to contribute 0.01 protons. So what's happened here? Well, another one of the reasons that Rutherford was wrong is the fact that atoms can have different masses but still be the same element. It's the number of protons that make an atom a member of one element, because that determines how it reacts. However, the number of neutrons will change the mass but not change the chemical properties. So atoms with the same number of protons but a different number of neutrons, and therefore a different mass, are called isotopes. And that's why some elements don't have whole number atomic masses in the periodic table, because this periodic table number is given as an average. Thanks very much for listening, Year 12. I hope you've enjoyed making your notes and will come fully prepared on Wednesday.